should recognize that there are a lot of new questions in this paper, right? So there's a lot of new questions in this particular paper, 2019. And that's what we're going to work through. So if majority repeat from this paper, all the better. So I'm expecting some great results, right? So it's really good to hear that the Unit 2 math, a lot repeated because they generally be consistent with both units of math. I don't know about the other CAPE subjects, but I know with math, if it repeat from 2014 to 2019, it's going to be the same for Unit 1. All right, so we're in good shape. With that being said, let's go. So the first question here says, how can this be simplified? Well, this is easy. Just put this in your calculator, right? I always like when we just do these questions in calculator. So calc mean use your calculator. Put this in your calculator and you're going to get minus 4.24. And then you can check which of these options is going to give you minus 4.24, and it's option B. So that's a nice way to do it. Just work it out, put it in a calculator, and then you're going to get an answer. So instead of having to simplify this by saying root 4 times root 2 plus root 4 times root 8 minus root 2 times root 81, you can just use a calculator. All right, so that's pretty simple. That's question 1. Question 2. Question 2 says that, so let's get rid of question 1. Question 2, if 3 is the remainder obtained when 8x cubed plus 4x plus k is divided by x minus 1, then k equals. So this is just remainder theorem. If we're dividing by this and remainder is 3, that means that f of 1 is equal to 3. That's what they're telling us. F of 1 is equal to 3. If f of 1 is equal to 3, what we then know is that 8 times 1 cube plus 4 times 1 plus k is equal to 3. 8 times 1 cube plus 4 times 1 plus k equal 3. And so clearly, k must be equal to, we bring everything to one side, and so we get k is going to be equal to -9. So that's question 2. All right, question 3. Question 3 says, what is the inverse of this conditional statement P implies Q? So the inverse of P implies Q is just putting a negation of the entire statement. And so the inverse is not P implies not Q. This is the inverse. Not P implies not Q. All right? And they can always change up this question, right? Sometimes they ask for the inverse. Sometimes they can ask for the converse. Sometimes we can ask for the contrapositive. Q implies P would be the converse. So the first one is the converse. The next one right here, why is this looking pinkish? Give me a second. Yeah, that's better. All right, not Q implies not P. This is the contrapositive. You can finish that, contrapositive. And this one is the inverse. Option C, we don't know what that is. All right, So it's imperative that we know all of them. That this statement P implies Q is known as the conditional statement. Q implies P is the converse of the conditional statement. Not Q implies not P is the contrapositive of the conditional statement. And not P implies not Q is the inverse of the conditional statement. So this is the conditional statement. I'm going to call conditional statement CS. CS for conditional statement. All right. Question 4. Question 4. So all we're doing is just rationalize. Well, you can look, this can be done two ways. You can rationalize this part, or you can just simplify it, right? So let's just simplify it instead of rationalizing it. So we can write this as 4 root x plus 4 times the root of 3 times the root of x divided by the root of 48 now. Now this root of 48, 48 is 16 times 3. So we can write it as the root of 16 times the root of 3. Nice. Now right here where we have this 4 cancels root 16, and this root 3 cancels this root 3. So what we're left with is to solve 4 root x plus root x, and that is just 5 root x. And that is option A, 5 root x. That's option A. Easy, soft. Option A. Question 5, this is a repeat question. So they're asking us which of the following are factors of this quadratic function, right? So all we're going to do is check which of them gives us 0, right? F of minus 1, is that going to give us 0? No, this one is not going to give 0. It's a repeat question. F of 1, this one is going to give us 0. And f of minus 2 is also going to give us 0. So what we can then say, or we can conclude, is that 2 and 3 are factors of this function right here, 2 and 3. Oh, so this paper is 2019, right? 2019 paper, this we're doing. And what I want to make from 2019 is that there are 25 new questions in this paper, 25 new questions, right? So if you haven't done 2019 as yet, you're gonna see some new questions, but don't worry about it. We're gonna go through all of them. And what I can say for those that just joined, the persons that did unit 2, many questions repeated from 2014 to 2019. So the point of me telling you this is to safely say that for consistency, I believe many of the questions are going to come from 2014 to 2019. All right, so we're going to do really well this year. So I'm expecting to hear some great results, just like the unit 2. So here we go. Here's a new question. This is a new question, question 6. It says the contrapositive of the statement, if Jomo is a minor, then he is rich. All right? So they want the contrapositive of this conditional statement. So remember, if P, then Q is a conditional statement. So this is a P implies Q. If P, then Q is a P implies Q. That's a conditional statement. What they want right here is the contrapositive of this conditional statement, right? And we just look at what the contrapositive is. This is the contrapositive. Not Q implies not P. So the contrapositive, I'm going to call contrapositive CP, is not Q implies not P. That's what they want. Not Q implies not P. All right, so first we have to identify our P and our Q. If P, this is our P, JOMO is a minor, so that's P. So write that down as P, if JOMO is a minor. Q is he is rich, that's Q. All right, so the first thing we need is not Q is going to be JOMO is not rich. So it's going to be, if JOMO is not rich, then JOMO is not a minor. So that's not Q implies not P. So if JOMO is not rich, so this one has it, if JOMO is not rich, then he is not a minor. So that's option C. So that's it. So this is the first new question. So I always like to write N for new question. So that's question 6, N. This is the first new question. I believe this one is a new question as well, question 3. All right, so these are new questions that haven't appeared on other papers before. So that's question 6, option C. Question 7, it says, given that f of x is equal to 3x squared minus 6x plus 1, the range of positive values of x for which f of x is 1 to 1 is, so they want the range of values of x to make this function 1 to 1. All right, so now I'm gonna do this question on a blank paper. 3x squared minus 6x plus 1. All right, so let's have a look at right here. We have 3x squared minus 6x plus 1. So this is a function f of x. All right, this is f of x.
Hello, hello, can you hear me?
Yes, I can hear you.
All right, sir.
All right. So now this question, f of x is, sorry for the poor handwriting, 3x squared minus 6x plus 1. Now this function right here, we can actually put it in the completed square form. In the completed square form, it would be 3 in bracket x minus 1 all square plus, I'm doing it in my head, that's minus 2. So I completed the square. All right, and so for persons that are wondering, how did I complete the square right here? There are 2 ways to complete the square, right? The first method is by finding xt, and xt is given by the formula minus b over a, minus b over 2a, right? xt is minus b over 2a, and yt is given by 4ac minus b squared over 4a. So this is the formula method that I use to complete the square. 4ac minus b squared over 4a. So if you're wondering where I get those values, this is how I get these values. Sometimes I see they refer to it as h and k, whatever the case may be. All I did was complete the square. All right, so this is stuff that we know from CSEC. Now the point that I'm trying to show you is this function right here, f of x, which is 3 times x minus 1 all square minus 2. If I'm to sketch a graph of this function, this is how it behaves. When you complete the square, completing the square allows you to find Where's the curve? Right here. So when we complete the square, what that allows us to do is to be able to can find the x, the turning point. So the point at which it turns is 1, -2. 1, -2. Let's just put 1, -2 right here. 1, -2. So this is the point 1, -2. 1, -2. So we're sketching this function. So this is how the function looks, something like this. My sketch is not accurate. Now, what I'm trying to do from this now, let's go to the question. The question says the range of values of positive values of x that will make the function 1-to-1. In order to make the function 1-to-1, this function that we have right here is, this function is what? This function is many to 1. So we need to make it be 1-to-1. So look how we're going to make it 1-to-1. We're going to remove this side from it. When we remove this side from it, so we're going to remove either the left side or the right side. But since I said I want the positive side to stay, we remove the left side. So when we remove the left side, now look what we do have. This is the same function, but we're just restricting the domain from when x is greater than 1. Now restrict the domain to when x is greater than 1. We're just going to get a 1-to-1 function. And so that's the solution when x is greater than 1. So that is option A. So how we go about doing this question? We find the x value at the turning point, right? So all you have to do is find xt, which is equal to minus b over 2a. So xt is minus 6 over 2a, and 2a is 2 times 3, and so 6 over 6 is equal to 1, and the solution is always going to be either x is greater than xt or x is less than xt. So x is greater than xt, so the solution is x is greater than 1. I only did the schematic or the sketch so we can see what is going on, but that is question 7a. So this is another new question. So let me write it right here, N for new. This is a new question. Easy, soft. Question 8. Question 8 they're asking us, find alpha squared plus beta squared. This is a repeat question that we do every week. Alpha squared plus beta squared is just going to be alpha squared plus beta squared is equal to alpha plus beta all squared. So it's equal to alpha plus beta all squared minus 2 alpha beta. Now alpha plus beta is the sum, which is equal to P, and alpha beta is equal to Q. So it's just equal to P squared minus 2Q. That is option D. Option C. Option C. All right, so 3 questions repeated out of the first 8 questions. So let's move on to question 9. All right. Question 9 is another new question, right? And what this is asking, it says, when t times x cubed plus t squared x squared plus t cubed x plus t to the 4 is divided by x minus t, what is the remainder? All right, so you can call this function f of x. Let's call that function f of x. That's our f of x, right? F of x. F of x is all of this function, right? but we don't want f of x. They said when it is divided by x minus t, what's the remainder? So f of t is going to give us the remainder. F of t is going to give us the remainder r. F of t is going to give us the remainder r. All right? So we need to find what is f of t. So we're going to put t where x is. So we'll put t where x is. We're getting f of t is actually going to be equal to, if we put t where x is, we get t times t cubed is t to the 4 plus, we'll put t right here again, we'll get t to the 4 plus t to the 4 plus t to the 4. So we're adding t to the 4 times, and so it is 4t to the 4. So it is right here, 4t to the 4, and that is option C. So that's question 9. This is another new question as well. So that's the 4th new question. Easy, soft. All right. Question 10. Question 10, this is a repeat question. I believe it's option B. But let's just work it out for those that want to see the working out. So right here, first we're going to have to write it as 1 logarithm. I don't like to write log, I always write lg for log. Right? lg, log, whatever you want to write. So the log of 4x over 7, that's when you write it as 1 logarithm. Because remember, log a plus log b is log ab. So log a of 4x over 7 is equal to 2. And so what we're practically saying then is by rules of logarithm, a squared is equal to 4x over 7. Then we make x the subject from this. So we have a squared is equal to 4x over 7.
Hold on, sir, when you log both sides,
Repeat.
when you log both sides.
When I take the log,
Yes, sir.
oh yes, so when we just rewrite it from this form, so all I did was rewrite it from this form. So we know this log a of some number n is equal to p. Then what that means is that a to the p equal n. Right? That's the first rule of logarithm. Right? Logarithm is linked to powers. Right? So that's a rule. So that's all I did right here, was link it to if log a of 4x over 7 is equal to 2. So a squared is 4x over 7. And so then we just make x the subject. Make x the subject, and we're going to get this right here. And that's
So,
option B.
can you scroll up there so I can see the questions from 1 to 8? I just want to see a sneak peek.
Okay, questions 1 to 8. Give me a second. All right.
Okay. So could you WhatsApp me the link when you're done?
Yeah. All right. So you seen all the questions?
Yes, sir.
All right. All right. Question 11. Question 11 is another new question. This is a what? 4th new question. It says if log base a of 16 is equal to 5, then what is log to base 2 of a? This may appear tricky, but it's very easy. So log base a of 16 is 5. So log base a of 16 is 5. So then what that tells us? What they're practically telling us then is that a to the fifth is equal to 16. That's what they're telling us, right? If a to the fifth is equal to 16, then what they're also telling us is that a is equal to 16 to the 1/5 power, right? A is equal to 16 to the 1/5 power. Agree with that?
Well, if you take the fifth root on both sides.
The fifth root on both sides. Very good. So now we can find log to base 2 of a. Now log to base 2 of a is going to be log to base 2 of 16 to the 1/5 power. Agreed? Because a is 16 to the 1/5. Agreed?
Yes, sir.
By rules of logarithm, we can bring down that 1/5 now to write 1/5 log to base 2 of 16. When you reach right here, you can solve it two ways. You can use change of base law and do this question, or you can just work it out normally. So let's work it out normally. So what we're going to do is write this as 1/5. Now look at this now. 16 can be written as 2 to the 4th power. So this is log to base 2 of 2 to the 4th power. We can then bring down that 4 to write 4/5 log to base 2 of 2. Then what is log to base 2 of 2?
1.
Log to base 2 of 2 is 1. And so the final solution is 4/5. As we said, when you got to here, you could have also used change of base law, where we could have rewritten this as 1/5, then change this to base 10, we could write it as log to base 10 of 16 divided by log to base 2. When you change it to base 10, you can put it in your calculator. That's the good thing about base 10. So then you could put in your calculator log 16 over log 2. Put that in a calculator, and you're going to get 4, and then the 4 times 1/5 is still 4/5. So that's what you can do to solve that question.
Can you explain number 7?
Number 7. All right.
I wasn't here for that, sorry.
Okay, that's fine. Let's go back to number 7. Number 7. All right.
Sir, what is this paper, 2019?
2019, yes. And in 2019, there are 25 new questions. Yeah, I don't know how they so wicked last year to these persons.
Sir, we're only
Must
doing
have them on the Wednesday, no, sir.
Go ahead.
we're
I got
only
them on the Wednesday.
No, not you, Asani.
we're only doing 2019, or we're going down.
Okay, so we've completed all the papers coming up from 2007 to 2019. But what I'd like you to do is send me an email so I can send you all the solutions and the video recordings of those classes. Is that fine?
Yes, sir.
Yes, sir.
Please and thanks. That will be useful.
Okay. So
Oh yes, sir. You know that you just sent to me and I sent to my group.
repeat.
Usually I send it to you. You saw I was sent to me and sent to my group, but I realized some people are different schools.
Yes.
I just joined today.
Yeah, understand. All right, so just send me an email in the chat. All right.
Wait, hold on, sir. You said something about in 2019 there were 25 new questions or something like that?
Yes, there are 25 new questions from this paper.
Drew, this.
Yeah, so don't worry
What
about
you
it. That's why we're
recommend
going
is-
through it.
Some of them are quite. You just have to understand how to do most of them.
Sir, what's your name in the group?
Look for Ferguson.
Okay. You could, I don't see it. Could
All right,
someone?
just send it generally in the chat. I'll see it.
Okay.
All right.
So just email you and you will send us the papers.
Yeah, so just type your email and I'm going to WhatsApp you the papers with all the solutions from 2007 coming up to 2019. But today, we're just going to be doing 2019 and the specimen paper.
No problem.
All right.
Great.
All right, so right here, you said you want us to go back through question 7. So let's look at question 7 now. It says, given that f of x is 3x squared minus 6x plus 1, find the range of positive values of x for which f of x is a one-to-one function. So first and foremost, this is a quadratic. My apologies. So first and foremost, this is a quadratic function. And what we know about quadratic function is that it is many to one. So that's what we know about a quadratic function, right? So for right here, we were discussing how a quadratic function looks. This is how the quadratic would look, right? So we complete the square to find the turning point. And we found that the turning point is 1 minus 2. This is the value of the c-intercept, so it passes through right here at 1. All right. Now we want the value of x that is going to make, or we want rather the range of values of x that is going to make the function one-to-one. Now this is a many-to-one function because as we can see, we have we have two x values right here being mapped to the same point, right? So clearly we can see that this is many to one. So what we want now, this is a quadratic, right? That's a quadratic. And right here is the x value at the turning point. I like to call it xt. All right, to make a quadratic one-to-one, we can either take the left side, and that would be when x, the range of values would be when x is less than xt. This would make the function one-to-one if we're sketching it on a graph. Or we can take just the right-hand side of it when x is greater than xt. Agreed?
Mm-hmm.
So we can take when either x is less than xt or when x is greater than xt, and that is going to give us the x value at the turning point. All right? And then that also gives us the range of values of x for which the function is one-to-one. So going back right here, we found that the x value of the turning point is 1. And so therefore, this now is the one-to-one function. For when x is from 1 to infinity, x is 1. The function f of x is 1-to-1. And so therefore, right here, when x is greater than 1, the function is a 1-to-1 function. It's a 1-to-1 mapping. So that answers the question?
Yes, sir.
Mm-hmm.
All right. So that's question 7. All right, let's continue with where we left off. So we looked at question 11. We're at question 12. All right. So question 12 is asking us, it gives us the domain of a function. So some function lies between -1 and 3, and it's a cubic function. So find its range. Its range are the actual y values that corresponds to these functions. So what I'd like you to do is this is the mapping diagram, right? We are used to the mapping diagram from C6. So you write x, and they write the range diagram, which is f, or some people write f of x, right? So put your mapping diagram, and the domain they give you is -1, 0, continue all the way down to 3. So when x is -1, you put it into the function. -1 cubed is -1, -1. That gives you -2. When x is 0, you're going to get 0 minus 1, which is minus 1. And you continue to 3. You put in 3, you get 27 minus 1. And 27 minus 1 is 26. So the range of values for f, which is the range, is minus 2, minus 1, 0, 7, and 26. So all I have to do is just draw your mapping diagram. Soft, C-set question. Let's draw your mapping diagram. That's all they're asking. All right. That's question 12. Question 13. Question 13 is asking us, find the values of x that is going to satisfy this inequality. All right. To find the values of x that is going to satisfy the inequality, what we need to do first and foremost is square both sides. Whenever you have modulus, you square both sides to get rid of the modulus. All right, so we square both sides, and we're going to have 2x minus a all square is greater than x squared. That's what we're going to have. So now we have an inequality to solve. So we just need to expand the bracket on the left-hand side to get 4x squared minus 4xa plus a squared, and that's greater than x squared. And that's greater than x squared. All right, when you get to this part now, what you need to do then is just bring over the x squared onto this side. So we'll bring over the x squared onto this side. We're going to get 3x squared minus 4xa plus a squared is greater than 0. So now what we end up with is a quadratic inequality. So we're then going to solve a quadratic inequality. So all you have to do is factorize first and foremost. So we're going to factorize when it is greater than 0. That's the first step, we're factorizing. So we're going to factorize 3x squared, and 3x squared can be factorized as 3x times x. All right. Now a squared, the only way we can factor a squared is for it to be a and a. And we'll put minus and minus. Now always check it back. This times this gives us 3x squared. This times this gives us a squared. And the sum in the middle is 3xa and ax, which is still minus 4xa. So this is right. Now, let's go to a new sketch right here. And let's just look what happened with a quadratic, right? This is a general idea of a quadratic. When we solve a quadratic equation equal to 0, so this is the line y equals 0. When we solve a quadratic equation equal to 0, what we get are the roots. Right? What we get are the roots of the quadratic equation. That's when we solve for when a quadratic is equal to 0. When we solve for when a quadratic is greater than 0, so this is now a quadratic when it is greater than 0. Right? So we no longer want what is below here. So we're solving when the quadratic y is greater than 0. This is what we have left. This is the part of the quadratic that is left. So it is when x is less than the first root. So let's say the roots are root 1 and root 2 is when x is less than the first root and x is greater than the second root. That's when the quadratic is being solved to be greater than 0. And finally, they can also ask for when the quadratic is less than 0. Right? When y is less than 0. They want to solve a quadratic less than 0. To solve a quadratic less than 0, that's inside here. Not very good with shading, but we notice the region that we're talking about. This is the
And
region.
if y is greater than 0, it's above the line x equals 0.
Yes, it's above the line y equals 0. All right. So now this is just a general idea of what's happening when we need to solve a quadratic that is greater than 0. So let's go back to the question now. So the question is asking when this is greater than 0. So as we just discussed, it is greater than 0 in this case when x is less than the first root and x is greater than the second root. So therefore, x is going to be less than this first root. So x is less than a over 3 and x is greater than a. That is option A. That's option A. That's question 13. Easy, easy question. Soft. All right. Question 14. This is the 5th new question. Let me write N. N for new. This question is asking which of the following graphs represent the function y equals 3 over x. All right. So first and foremost, we should know how to sketch functions of the form y equal a over x. So let's look at this. Y is equal to, I'm going to start with a simple one. Y equal 1 over x. Let's say y equal 1 over x. How would you sketch y equal 1 over x? Right? So you look at this, y equal 1 over x. When x is 0, the function is undefined. We don't know what it is. When x is 0, it is undefined. When x is something like 1, we get that y is 1. So let's say 1 is right here. This is 1. When x is 2, y is a half. When x is 3, y is a third. When x is 4, y is a quarter. And so what we notice is this is how the function is looking. It's never going to touch the y-axis and it's never going to touch the x-axis, right? That's for y equal 1 over x. You're wondering why I got 1 over x and not 3 over x? Because 1 over x is simple, right? And y equal 3 over x is a similar form to y equal 1 over x. All we're going to do is multiply it by 3 to get the graph y equal 3 over x. So don't worry about it. All right, now let's look on over this side now. When x is minus 1, what happened? We get y is minus 1. So we can put minus 1 somewhere right here. When x is minus 2, so this is minus 1. When x is minus 1, y is minus 1. When x is minus 2, y is minus a half. Minus a half could be somewhere right here. When x is minus 3, y is minus 1/3. And so what we're seeing is that this is a graph of y equal 1 over x. That's how the graph looks. All right. And so if you were to multiply this by 3 to get 3 over x, all we would change is the value right here, 1 and 1. We just change the values on the y-axis. And so this would just be 3. This would just be minus 3. So this would be the graph now of 3 over x. All right. Now what did the question ask for? The question asked us for the modulus. So this is the graph of y equal 3 over x. And so y equal the modulus of 3 over x. What does modulus do? reflect everything that is below
And
the
the
x-axis
positive.
over the x-axis. And so if this was the graph, we're going to reflect this bottom part over the x-axis, so it becomes like this. And so that's the graph of y equal the modulus of 3 over x. We just reflect this side above the x-axis. All right? So that's a very easy question, and that is option A. So this is a new question as well. This is a 6th new question. All right? New question, but it is easy, soft. All right? All right, so I'm getting the emails. I'm getting the emails. Yes.
So you got mine?
Yes. So when we finish our session, I'm going to send all the past papers to the emails. All right? We'll finish the session. So don't worry
Yes, sir.
about it. All
So
right.
the links mostly, sir.
Yes, the link, the paper, and the solutions from
Yes, sir.
2007 to 2019. All
Yes,
right.
sir.
All right. Let's go. Let's continue. Question 15. It says, given that alpha, 2 alpha, and 3 alpha are the roots of the equation x cubed plus kx squared plus 48 equals 0, it says, find the value of the constant. All right? Find the value of the constant. So let's find the value of the constant. Now, this is a cubic equation, right? And what we know about cubic equation, we know that the sum of all the roots of a cubic equation is minus b over a. So the sum of all of this cubic equation is minus k over 1, which is minus k. So that's the sum. The next thing we know is that the product of all the roots, in this case, the product of the 3 roots are going to be 3 alpha times 2 alpha times alpha. That's going to work out to be 6 alpha cube, and that product is equal to 6 alpha cube is equal to minus d over a. So it's equal to minus 48. So what we're seeing then is that alpha must be equal to negative 2 in order for the equation to be true. Alpha is negative 2. If alpha is negative 2, k, remember, is negative s. So k is the negative sum. K is the negative sum, negative s. And what is the sum? So k is equal to minus alpha plus 2 alpha plus 3 alpha is 6 alpha. So k is minus 6 alpha. But then what is alpha? Alpha is negative 2. And so negative 2 times 6 is negative 12, times negative 1 is positive 12. And so k is 12. That's the value of k. Very easy question. That's question 15. All right. Easy, soft, the capital T. All right. Let's go. Question 16. Question 16 gives us a vector A and a vector B, and it asks us to find the modulus of 3A plus 2B. All right? So to find the modulus of 3A plus 2B, first we need to find the vector 3A plus 2B. So the vector 3A plus 2B is 3 times minus 3, 7, plus, so that's 3 times vector A, plus 2 times vector B. Vector B is 2 minus 1. And so we need to find 3 times vector A. 3 times minus 3 plus 2 times 2, that is negative 9 plus 4, that's negative 5. And then 3 times 7 is 21, plus negative 2, that's 19. All right. So now we have this vector, that is vector 3A plus 2B, right? So let's call 3A plus 2B V, right? So this is vector V. Now what they want is the modulus of vector v. The modulus of vector v now is just going to be -5 square plus 19 square all square rooted. That's the modulus of the vector. That's how you find the length of the vector. A squared plus b squared all square rooted. And 5 squared plus 19 squared, that is the root of 386. That is option B. That is option B. All right, that's question 16. Easy question, soft. All right, soft. That's question 16. Let's have a look at question 17. Question 17, it says find the value of cosine pi by 2 minus p. To find the value of cosine pi by 2 minus p, well, that's going to equal to cosine. So we're going to use compound angle, and compound angle tells us that this is cosine pi by 2 times the cosine of p minus, well, when it's minus, it becomes plus right here, plus the sine of pi by 2 times the sine of p. So that's the compound angle formula we're using. Sine of pi by 2 times the sine of p. Now the cosine of pi by 2, remember, is 0. And so 0 times cos p is 0. So it equal to 0 plus the sine of pi by 2 times the sine of p. The sine of pi by 2 is 1. And so it end up work out to be 0 plus 1 times sine p. And so all of this works out to just be option A, sine p. Easy question, soft. All right. Question 18. Question 18 is asking us to find the value of theta that is going to satisfy this cubic equation. Well, this quadratic equation. Let me get a little zoom. Yeah, quadratic equation. All right. So we have a trigonometric quadratic equation to solve. And so we can just factorize it and solve it. So let's factorize it. Now, in order to get 2 cos squared theta, it has to be 2 cos theta and cos theta. That's the only way we're going to get 2 cos squared theta. So it's cos theta and 2 cos theta. In order to get 2, it has to be 2 and 1. So it has to be 2 and it has to be 1. Now, the next thing that we need, it says it needs to be plus 3 cos theta. So we're going to put the plus 2 right here and put the minus right here. All right. So now that's what we're solving. We're solving 2 cos theta minus 1 equals 0, or cos theta plus 2 equals 0. So from this first one right here, if we're solving 2 cos theta minus 1 equals 0, then what we're solving then is that the cos of theta is equal to 1/2. If the cos of theta is equal to 1/2, then theta is cos inverse of 1/2, and we know that cos of 60 degrees is 1/2. Cos of 60 degrees is 1/2. Now, which one of these is 60? That's pi by 3. So that's question 18. Answer is C. Easy question. All right. And Justin, don't worry about it. I'm going to email these papers to everyone. All right. So don't worry about it. Everyone is going to get the email as soon as we finish this session. All of the papers are going to be sent. All right. So that's question 18. Question 19. This is a new question. N for new. right? It says a curve is given by parametric equation x equals 3t plus 2 and y equal t squared plus t minus 6. And then it is asking for the Cartesian equation. So x is 3t plus 2 and y equal t squared plus t minus 6. So I need a little bit more space, so I'm going to copy the question right here. So it says x is 3t plus 2. X is 3t plus 2. And they said y is equal to, I can't remember, let's go back to what it says. It says y is equal to t squared plus t minus 6. Y is equal to t squared plus t minus 6. T squared plus t minus 6. All right. So that's what they said. And they said they want the Cartesian equation. Cartesian equation is y written in terms of x. So from this one right here, we're going to make t the subject. So to make t the subject, we're going to find that t is equal to, we'll bring over the 2 and we'll get x minus 2 over 3. That's what t is equal to from this equation, x minus 2 over 3. So that's t. We can then substitute t into this equation. So let's do that. So we're going to substitute t into that equation to get y is equal to x minus 2 over 3 all square x minus 2 over 3 all square plus x minus 2 over 3, because that is t, minus 6. That's what y is equal to. All right? Now, I'm going to go to this question just for a quick to look at the answers that we have. Notice that all of them has 9y on it, right? So since all of them has 9y on it, we're just going to multiply this entire equation by 9. So we're going to multiply this entire equation that we have by 9, both the left hand and the right hand side. So we're going to multiply it by 9. So then what we're going to get is that 9y is equal to 9 times everything in here. It's going to work out to be 9 times, in the numerator we have x minus 2 square over 3 square. Over 3 square. Now 9 over 3 square, that part is going to cancel. Plus 9 times x minus 2 over 3. So we have 9 times x minus 2 over 3 minus 9 times 6 is negative 54. All right, so we're almost there. Now, as we said, this 9 cancel. 9 over 3 square cancels. 3 into itself goes 1 time. And this leaves 3 times. So what we're getting now is 9y. Let's continue. 9y is equal to, this is going to simplify to be x minus 2 all squared, right? So we're continuing down there. Let me put the arrow. So 9y is equal to x minus 2 all squared. X minus 2 all squared is just x squared minus 4x plus 4. Now 3 times x is just plus 3x. Then 3 times negative 2 is minus 6. Then we have minus 54. That's 9y. All right, so we're almost there. We're finally done. So let's just write the final answer. Let's write it in brown. Final answer in brown. So 9y is equal to x squared. That's the first one we see, x squared. Now we're going to be grouping the x terms. We have minus 4x and plus 3x. So that works out to just be minus x. And then we have 4 minus 6 minus 54. So 4 minus 6 is negative 2. Negative 2 minus 54 is negative 56. So that's x squared minus x minus 56. This is the answer. A, N, S. Easy question, soft. So that's 9y is equal to x squared minus x minus 56. All right, so that is option A. Easy, soft. All right, easy, soft. With a capital T. Easy. So this is 2019 paper. All right, 2019. All right, question 20. Question 20 is asking us to find the value of cosine 75 sine 15 minus sine 75 cosine 15. Now I want to show you something. Remember we just did this question. The cosine of 90 minus p is the sine of p. There's a reason why I'm showing you this. The cosine of 90 minus p is sine p. Why am I showing you this? Let me show you why now. We're going to use this part to answer the next question. So we just learned that the cosine of 90 minus p, cosine of 90 minus p is equal to the sine of p. That's what we just learned. Why am I showing you this? If p is equal to 15 degrees, then what I'm trying to tell you then is that if p is 15, we're going to get that the cosine of 90 minus 15, which is 75, the cosine of 75 is equal to the sine of 15. Ah, the cosine of 75 is the sine of 15. And what else do we know? The next thing is that if p was 75, then we'd see that the cosine of 15 is the sine of 75. The cosine of 15 is equal to the sine of 75. So there's a reason why I'm showing you this. Right? So let's go back to the question now. The question said, find the value of cosine 75 sine 15 minus sine 75 cosine 15. Now I just showed you that sine 15 is the same as the cosine of 75. So I'm going to rewrite this now as, since sine 15 is the same as cosine 75, this question is asking me for cosine 75 squared minus sine 75 is the same as cosine 15. So it's asking me for cosine 75 squared minus cosine 15 squared. Ah, that made the question so much easier. So all we have to do is put this in our calculator. When you put it in your calculator, you're going to get minus 0.86. And that is minus root 3 over 2. Minus root 3 over 2. Easy, soft, the capital T. So that's all we had to do for that question. So as we said, cosine 75 is the same as sine 15. How do we know that? It's from this principle that we just found out. We found out that the cosine of 90 minus p is the sine of p. So the cosine of 90 minus 15 is the sine of 15, and the cosine of 90 minus 75 is the sine of 75. So we could have used that principle to help us solve this question to get option B. All right, so let's go back to why we squared it. I squared it because, as we said, the sine of 15 is equal to the cosine of 75. So I can replace sine 15 with cos 75. That's virtually what I'm saying. I'm saying sine 15 is the same as cosine 75. So cosine 75 times cosine 75 is cosine 75 squared. And likewise, I can replace sine 75 with cosine 15. And so cosine 15 times cosine 15 is cosine 15 squared. All right, so that's why I write square right there. So that's why I can put it in a calculator now. All right, and so that is question 20. Easy, soft, the capital T. All right, let's go to question 21. Question 21 is asking us to find the set of values of k for which the straight line y equal kx minus 4 intersects the curve with equation y equal to x squared minus 2x at two distinct points. So it wants us to find the values of k where the straight line intersects the curve. So let's find that now, where the straight line is going to intersect the curve at two distinct points. So what does that mean? A curve intersecting a line at two distinct points. So I'm going to sketch it. All right. So if I have a curve, this is a curve, and I have a line now, this is the only way they meet at two distinct points, is if the line cut the curve at 2 points. So they want the value of k that is going to make the line cut the curve at 2 points. Because this is where it would cut the curve at 2 points. There's also a possibility that the line can cut the curve at 1 point. We call that line a tangent to the curve. So let's say the line looks something like this. It only cuts it at this point. Then we say the line is a tangent to the curve. And then you have another case where this is the curve and this is the line. They never intersect. So looking at option A, when the line cuts the curve at two distinct points. So let's look at that now. That's what the question wants. So they told us that the equation of the line is y is equal to kx minus 4 and y is equal to x squared minus 2x. Just for us to know, this is a new question as well. All right, so another new question. They were very tough on the 2019 persons. I don't know why. All right, so y is kx minus 4. So y is kx minus 4, and y is also the curve x squared minus 2x. So if both of them are y, all we need to do is to solve the two equations simultaneously. So let's solve them simultaneously. All right. Nerissa, don't worry. As I'm saying, as soon as the class is finished, I'm going to send all the papers with all the solution. All right. As soon as our session is finished. All right. So right here, we're solving the equation of the line and the curve simultaneously. And so all we need to do is equate the two of them. So we're going to equate them as x squared minus 2x. X squared minus 2x is equal to kx minus 4. X squared minus 2x is equal to kx minus 4. So now we can bring everything on one side to get x squared minus 2x minus kx plus 4 is equal to 0. X squared minus 2x minus kx plus 4 is equal to 0. Now the question is looking easy to solve. Because now we can just write this as x squared. Now look what I'm going to do. I need to just have it as something times x. So I'm going to factor out my x now. So I'm going to write plus in bracket. This is minus 2 minus k times x plus 4 is equal to 0. All right? Plus 4 is equal to 0. All right. Now this question, they're asking what's the value of k that is going to make the line intersect the curve at 2 distinct points. Now the only way the line intersects the curve at 2 distinct points is this. So there's something known as discriminant. So what is going to happen is that the discriminant must be greater than 0. Discriminant must be greater than 0 for the curve to intersect the line at 2 distinct points. That's the only way. Discriminant must be greater than 0. Now, what is discriminant, right? So from odd math days, we learned that the discriminant is b squared minus 4ac. That's what we call discriminant, right? So in the quadratic function, the thing that goes under the square root is a discriminant. This is the discriminant. So I like to call discriminant D. Discriminant D, right? The discriminant is D. So now, the only way that it's going to intersect the curve at 2 distinct points is if the discriminant is greater than 0. So what we're saying then is that minus 2 minus k all square, that's your b in this case, for the quadratic, minus, that's your b, minus 4 times a. A is the coefficient of x squared, which is 1. C is the coefficient of our constant, which is 4. And that must be greater than 0. So this is what we're solving now. So we're solving minus 2 minus k all squared minus 4 times 1 times 4 is greater than 0. So what this implies that we're solving is that part works out to be 4 plus minus 2 times minus, that looks like 4k plus k squared minus 16 is greater than 0. So I'm going to go around here now. 4 plus 4k plus k squared minus 16 is greater than 0. This can be simplified to be k squared plus 4k minus 12. So it's working out to be k squared plus 4k minus 12 is greater than 0. So we can factorize it. And when it's greater than 0.
Divide by 4.
Repeat.
Oh, never mind, sorry.
So we have k and k, right? And we need to get it to be 12 right here. So it has to be 6 and 2. And we need it to be plus and minus. So let's look at it balanced right here. So let's look, k times k gives us k squared. K times 6 gives me 6k. Minus 2k is indeed 4k. So this is true. All right. So this is what it has to be. K has to be now. So now let's sketch it. So if we were to put it on a graph, this is the quadratic that we have, and we have -6, and we have 2. That's what we have. So this is when k is -6, and this is when k is 2. But we want when it is greater than 0. It's going to be greater than 0. This is the line y equals 0. And we want when it's greater than 0, so that's when it's above the line y equals 0. So it is above the line y equals 0 when k is less than -6, and when k is less than -6, union k is greater than 2. So let me just give you a number example. For example, try the number k equal 3. When k is 3, you're going to get 3 squared plus 4k. 3 is 9. 3 squared is 9. Plus 4 times 3 is 12. So 9 plus 12 minus 12 is 9. 9 is greater than 0. Now try when k is something like -7. -7 would be -7 squared is 49 minus 28 minus 12, and that's also going to be greater than 0. And so this is the solution when k is less than -6 and k is greater than 2. All right, so this question was testing our knowledge of discriminants. So k is less than -6 and k is greater than 2. Easy question. It was lengthy, but it's very easy. Soft, a capital T. All right, so that's question 21. Very easy question. All right, question 22. Question 22. It says the curves y squared is equal to x plus 7 and xy equals 6. And they intersect at 3 points. Find the y coordinates. So y squared is x plus 7 and xy equals 6. So we're doing a simultaneous equation. So let's do it right here. Y squared is x plus 7 and xy equals 6. And they want the y coordinates. So since they only want the y coordinates, then what that means is that we really don't need to find the x coordinates. We only need to find the y coordinates. So let's just find the y coordinate. This has a y square in it, and so I don't like y squared to be subject. I like something simpler, x. So let's make x the subject, and making x the subject, x is y squared minus 7. And then xy is equal to 6. And so xy is going to be, this is now our x, y squared minus 7 times y is equal to 6. And so what we end up having now is that this is now y cubed minus 7y. And we'll bring over the 6 over here. It will become minus 6 is equal to 0. So now we have a cubic equation. So I can put the 3 factors, 1, 2, 3, and it's equal to 0. In order to get y cubed, it has to be y, y, and y. You have to multiply y, y, and y. All right. In order to get 6, it has to be 3, 2, and 1. That's what it has to be. It has to be 3, 2, and 1 in order for it to multiply to be 6. Now the trick question is how we're going to get it to be minus 6. So we need 2 to be negative, and 1 to be positive. That's how it's going to be negative. Or we need all 3 of them to be negative. But then if all 3 of them is negative, we need to remember if all 3 of them is negative, it shouldn't work out that the product by 2 is negative. The product by 2 is only going to be negative if 2 of them is going to be negative. All right? So I'm going to put minus, plus, plus. All right? And we work it back out. This gives us the y cubed. 1 times 2 is 2. 2 times negative 3 is negative 6. Voila. So this is right. So from all of this, we're getting that y is negative 1, y is negative 2, and y is positive 3. So we've solved the question very easily. Y is negative 1, y is negative 2, and y is 3. So here is the solution, the very first one. Y is negative 2, y is negative 1, y is 3. Easy, soft. All right. Question 23. Question 23 is the easiest question on the paper. It says 2 sine square theta plus 2 cos square theta times sec square minus tan square. Now 2 times sine square theta plus cos square theta. If I were to factor out 2, I'm left back with sine square plus cos square. But sine square plus cos square, as we know it, is 1. So sine square plus cos square is 1. And so this part is going to work out to be P is equal to 2 times sec square minus tan square. So P is 2 times sec square minus tan square. But then what is sec square theta? Sec square theta is 1 plus tan square theta. That's an identity. We should know that sec square is 1 plus tan square. So this works out to be 1 plus tan square, 1 plus tan square minus tan square. 1 plus tan square minus tan square. Easy question. And so 1 plus tan square minus tan square, and we're multiplying that by 2. That works out to be 2 times 1 plus tan square minus tan square. Tan square minus tan square is 0. So we'll multiply it by 1. So 2 times 1 is just 2. That's option A. Easy question. Soft with a capital T. All right. Question 24. This is the nicest question on the paper. Anything with parametric equation or vectors. Vectors is my favorite topic. So let's put that 24. This is a new question, N for new. It says the curve whose Cartesian equation is x minus 3 all square over 16 plus y plus 4 all square over 9 is equal to 1. Find the parametric equation. So usually they give you the parametric and ask you for the Cartesian. Now they give you the Cartesian and ask you for the parametric. So this is how we do that question. All right, so they gave us x minus 3 all square over 16 plus y plus 4 over 9, y plus 4 all square over 9. They said that's equal to 1. Yes, Mr. Brown, I will send you the papers, all right? So as I said, as soon as we finish this session, I'm going to send everyone the papers. And I'm going to send all the papers from 2007 to 2019 with the solutions. All right, so don't worry about it. As soon as the session is finished, we'll all get the papers. All right. So let's just finish this session. All right. So we have y plus 4 all square over 9 is equal to 1. Now look at the question, guys. How you think we're going to work it? Notice that x and y having some trick in it. Ah, easy. This one right here, I can write 1 as sine square theta plus cos square theta. So I'm going to rewrite 1 as cos square t plus sine square t. But that's 1. 1 is equal to cos square plus sine square. So that's 1. 1 is cos square plus sine square. Any way you would do it is fine. Whether you say sine square plus cos square or cos square plus sine square, either is fine. But I like to say cos square plus sine square because C come before S in the dictionary. All right, C come before S. So that's how I like to write it. C come before S. All right. So now look what I'm going to do. Since this is equal to 1 and 1 is cos square t plus sine square t, I'm going to be equating this right here, x minus 3 all square over 16 is equal to cos square t, and then I'm going to be equating y plus 4 all square over 9 is equal to sine square t. So let's solve them now. So I'm saying now, from the red, so look at the ones that are in red. From the ones that are in red, we see that x minus 3 all square, x minus 3 all square over 16 is equal to cos square t. Cos square t. All right, now look at this now. If I square root both sides, if I take the square root of both sides, so I'm going to take the square root of both sides, take the square root of both sides. What is going to happen then is when I square root it, x minus 3 squared, when I square root that, I left back with x minus 3. When I square root 16, I am getting 4. When I square root cos squared t, when I square root it, I'm just going to left back with cosine t. So from this, I can make x the subject easily. So x, all right, guys, now there's a trick to this question. What is the trick? Is when you square root, as we all know, when you square root, you get plus or minus. So always write down plus or minus just in case, right? Always write down plus or minus just in case. There are 2 answers we can get. Always bear that in mind. So x is going to be equal to, if we're working with the positive one, we're going to get that x is equal to 4 cosine t, 4 cosine t, 4 cosine t, and then we'll bring over the 3, and we'll get plus 3, right? That's if we're working with the positive one. Remember, as we said, we get plus or minus when we square root cosine of t. So that's 4 cosine t plus 3. That's what we're getting with for x. X is 4 cosine t plus 3. We'll soon look at the minus one, right? Because we don't know if the solution is going to be for the positive one or the minus one. So let's just keep it for the positive one. Let's just keep it for the positive one. All right. Now let's look at sine square now. So we have y plus 4 all square over 9 is equal to sine square t. Y plus 4 all square over 9 is equal to sine square t. If we're going to square root both sides, what we then notice is that what we're getting is that y plus 4 And then when we square root 9, we're getting 3. So y plus 4 over 3 is equal to plus or minus the sine of t. So from this one, there are two possible solutions, but I'm going to just look at the solution with the positive. The solution with the positive is giving me that y is equal to 3 sine t minus 4. So y is equal to 3 sine t minus 4, and x is equal to 4 cos t plus 3. All right? And if you're writing down both solutions for the plus or minus, x can also be equal to minus 4 cosine t minus 3. This is for the negative solution. Minus 4 cosine t minus 3. And if you're writing down the negative solutions for this one, it is just minus sine t, bring over the 3. It would be minus 3 sine t minus 4. Minus 3 sine t minus 4. But we don't really need negative one. Let's just look at which solutions they give us for. All right, so there it is. It is one with the negative solution. It's option D. X is negative 3 minus 4 cosine t. Here we have it. Negative 4 cosine t minus 3 is the same as negative 3 minus 4 cosine t. And sine is negative 4 plus 3 sine t. Negative 4 plus 3 sine t. So that's option D. So question 24, soft with a capital T. Easy, soft, right? So this question was easy. That's question 24. So this was us testing our knowledge of just rewriting 1 as sine square plus cos square, or writing 1 as cos square plus sine square. All right, why couldn't it be option C? X is 3 plus 4 sine theta, and y is minus 4 plus 3 cosine theta. So in this case, what you're saying is that you let it be something with sine, right? So if you let it be something with sine, that means that you would have, so what you did was equated x minus 3 all square over 60 into sine square, and you equate y plus 4 all square over 9 to cos square, right? So that's how you equated it. So if you equated it to this way right here, well, let's see. So Tonian asks why couldn't it be option C? So let's equate it the other way. So I equated it this way, right? So let's equate it Tonian's way and see what we're getting. Yes, Cheyenne, you can speak. So we're going to do it Tonian's way. X minus 3 over 4, we're going to write that as sine t. So this is Tonian's way. X minus 4 over 3 is equal to sine t. And then what we're saying is y plus 4 over 3 is cosine t. So let's see what we get now for x. So if we bring over this, we're going to see that x would be equal to 3 sine t plus 4. X is 3 sine t plus 4. And y would be equal to 3 cos t minus 4. 3 cos t minus 4. Whoa, this question, that is actually true as well. 3 sine t plus 4 and 3 cos t minus 4. 3 sine t plus 4. Is that what we got? We got 3 sine t plus 4. 3 sine t plus 4. And yes, go ahead.
I think I made a mistake. I think I made a mistake. You're supposed to have x minus 2 or 4 for one of them, and y plus 4 over 3 for the other one.
Go again, repeat, Leah.
I was saying you're supposed to have x minus 3 divided by 4 for one of them, and y plus 4 divided by 3 for the
I should have
other one.
x minus 3 divided by 4.
Yes, sir.
And y
And
plus
y
4.
plus 4 divided by 3. You
Yeah, that's,
realize the root is too much for both of them.
yeah, that's what we have right here, right? Wait,
No, sir. Change it to
wait, not this one.
mistake. X minus
X minus 3 divided by
I should have x minus 3 divided by 4. Oh, thank you. X minus 3 divided by 4. X minus 3 divided by 4. Thank you. X minus 3 divided by 4. And then I should have y plus 4. Yeah. So what this should be is 4 sine t. 4 sine t plus 3. Thank you for that. Thank you. 4 sine t plus 3. Or 3 plus 4 sine t. And y is going to be 3 cos t minus 4. Three plus 4 sine t. So 3 plus 4 sine t is option C right here. Yeah. 3 plus 4 sine t is right there. 3 plus 4 sine t. 3 plus 4 sine t. And then minus 4 plus 3 cos t. Minus 4 plus 3 cos t. Yeah. Yes, this is 2019 paper. All right, this was the year they gave 25 new questions. Whoa. A fresh batch of papers. All right, so that's option C, easy question. Question 25, it's asking for the cosine of the angle between two vectors. Now, in order to find the cosine of the angle between two vectors, let's call that angle theta, right? Now, and let's call this A and call this vector B. So what do we know about angles between vectors? The cosine of theta is given by A dot B dot product divided by the modulus of A times the modulus of B. That's what we know. Now A dot B is equal to A is the vector 0, -6, dot B is the vector 1, 1. And we're dividing it by the modulus of A. Now, if I have a vector 0, -6, then the modulus has to be 6. Think about it. The modulus has to be 6, right? Because this is just a straight line. So on a graph, if I have a vector 0, -6, this is -6. Then this is the length of the line from 0 to -6, that has just has a length of 6. And now I have vector 1, 1. Vector 1, 1 could be somewhere right here. And that's 1 square plus 1 square, square rooted. That's the root of 2. And so now just find the dot product in the numerator, and that works out to be -6 over 6 root 2. And so the 6 cancel with each other, and I'm getting -1 over the root of 2. That looks like option A. Easy question, soft. That's question 25. Question 26. Question 26 asks us for the maximum and the minimum value of this function. In order to find the maximum and the minimum value of this function, I always like to start with the inequality. This is the inequality I like to start with. Sine of theta must be between 1 and -1. This is a given. And so 2 plus sine theta, 2 plus sine theta must then be between, if I add 2 to both sides, it's going to be between 3, and adding 2 to both sides, I'm going to get 1. So now if I flip it and take 1 over 2 plus sine theta, from this inequality, what I'm getting then, when I flip it, when you flip it, you have to change the sign. So you change the sign now, and so 1 over 1, and this becomes 1 over 3. That's what happened when you flip it. All right, so what we're finding out then is that the minimum value is the least possible value, which is 1 over 3, and the maximum value is 1. And so it is 1 over 3 and 1. That's question 26. That's option D. Easy question, soft. That's question 26. All right, and don't worry about it. They're going to love you this year for 2020. For 2020, I believe they're going to repeat everything between the years of 2014 to 2019. All right, so don't worry about it. They like to be consistent, and given that for Unit 2, a lot of the questions from 2015 to 2019, I believe they're going to do the same for Unit 1. They like to be consistent with math. So that's an indicator that they're going to repeat questions. All right? So there won't be so many new questions, maybe about 5 or so, but no more than 5. I guarantee you. All right? Question 27. It says a circle has center -1, -1. All right, circle has center -1, -1, and the equation of the tangent to the circle is 0, -3. So we have a circle, and the center of the circle is 0, -3. So we have a circle. I like to draw my circle. This is the center, and then we have the point of tangency. So the center is -1, -1. That's the center. And we have some point 0, -3 on the circle, and they want the equation of the tangent. So I'm going to use a yellow line to represent the tangent. So this is a tangent. And I'm going to use a black line to represent the normal. And what they want is the equation of the tangent. So in order to find the equation of the tangent, we first need to find the gradient of the normal. The gradient of the normal is equal to y2 minus y1 over x2 minus x1. So y2 is -3 minus -1, that becomes +1 over x2, which is 0, minus x1, which is -1, which becomes +1. So the gradient of the normal is -2. If the gradient of the normal is -2, then the gradient of the tangent is 1/2. And so we're looking for something with the gradient being 1/2, and that is option B. Here it is, the gradient is 1/2. That's question 27. Easy, soft. Question 28. Question 28 says the distance in meters of an arm of a shaping machine from its starting position can be modeled by the equation D, which is equal to 12 cos theta plus 5 sin theta. Find the maximum distance in meters from the starting point. So to find the maximum distance from the starting point right here, we can say that D, the maximum distance, we can rewrite this now as D can be written as, so remember, we can always rewrite something from the form A cos theta plus B sin theta to R into cos theta, R into cos theta minus alpha, right? We can always rewrite it in that form where R is equal to A squared plus B squared. So we're going to rewrite it and we're going to get A squared, which is 12 squared plus 5 squared square rooted, and that's 13. So this is equal to 13 cosine theta minus alpha. And so the maximum value is going to be R. Remember, the maximum is R. Maximum is equal to R, which is 13. That's 13. There's another way to find the maximum point. We could use differentiation to find maximum point, because what we know about maximum point points occur when the derivative, the first derivative, is equal to 0. All right. So let's go back to where this 13 come from. Let's do it on a new, let's go to a new sheet. That should make it better. 12 cos theta, 5 sin theta. So let's do it right here. D is equal to 12 cos theta, 12 cos theta plus 5 sin theta. Right. Now, first and foremost, this is a general rule. So it's a general rule I'm going to write. Now, if f of theta, right, in this case, I'm going to write x. If f of x is equal to, let's say, a cos x plus b sin x, then f of x is equal to r cosine x minus a, where r is equal to a squared where r is equal to a squared plus b squared all square rooted. All right, so this is from the principles. Let's not call this A, let's call this one alpha. All right, so you're wondering where this come from. So this came from the principles of going back to compound formulas, right? Compound formulas. So let's go back through compound formulas. So let's go back to compound formulas. So before we're looking at this question, just revise compound formulas, the cosine of A plus B. Talk to me, what's the cosine of A plus B? Cosine of A plus B is cosine A cosine B minus sine A minus times sine B. That's compound angle formulas, right? We know this. So we know this is true, all right? So we know this is true. So what I'm saying is this right here, this at the top, B, which is 12 cos theta plus 5 sine theta, can also be written in a similar form to this right here. All right? So let's show you how we do that. So right here, let's write it now. So 12 times the cosine of theta plus 5 times the sine of theta, that can be written in the form r times the cosine of theta plus alpha. Well, theta minus alpha. It can be written in this form. So how are we going to find what r is? If you expand this right-hand side, what we're getting is r times the cosine of theta times the cosine of A plus r times the sine of theta times the sine of A. Now, the only way for these two equations to be equal is if this happens. 12 cosine theta right here. So this have cosine theta too. And so therefore we have r cosine theta cosine A is 12 cosine theta. So from this, I'm going to equate these two, and I'm going to get that 12 cosine theta.
13.
Repeat. Yes, the answer is 13. So someone asks, why is it 13? So we're going through why it is 13. So equate these two parts to get 12 cosine theta, and that's equal to r cosine theta times the cosine of A. If you divide both sides by cosine theta, what you're left with is 12 is equal to, give me a second. All right, sorry about that. Had a emergency call. So right here as we were saying, so 12 cos theta is r cosine theta times the cosine of A. And so if you were to cancel cosine on both sides, we see that 12 is equal to r cosine A. That's from that side. Now, if you're going to equate now, this side, I'm going to put in dark blue, in true blue. No, this is not true blue. So put right here now in true blue, 5 sine theta is equal to r sine theta sine A. If we put that in true blue, right, we notice that 5 sine theta is equal to r sine theta sine A. So looking at the true blue color, let me write it right here. Put some space right here. We'll see that r sine theta sine A is equal to 5 sine theta. And from that, then what we have is r sine A is equal to 5. So now look, look what we just found out. 12 is equal to r cos A, and r sine A is equal to 5, right? So r sine A is 5, and r cos A is 12. So now we have a triangle. This is a triangle, right? And we have some angle A, right? And the opposite is 5. The adjacent is 12. And so the hypotenuse is going to be 5 squared plus 12 square root, and that gives us 13, right? And so therefore r is 13, because r is going to be your what? R is going to be your hypotenuse. So r is 13. All right? And so therefore what we're saying is that all of this can be rewritten finally in blue to be 13 times cosine of theta minus A. So then how do we know that the maximum is 13? Because of this. We just discussed that the cosine of x is between 1 and negative 1, right? Cosine of x is between 1 and negative 1. And so 13 times the cosine of x is going to be between 13 and negative 13. And so the maximum is going to be 13. And so that's the reason why the maximum is 13. All right. So that's the maximum, which is 13. Question 29. Question 29 is a new question. So let's write new, N for new. It is asking us, it says, a vector equation for the line through the points A and B is R. And it says, find the vector equation, right? So how do we find vector equation? Now, vector equation, so now vector equation R, any vector equation R is equal to A plus T times B. And where this A come from? Where A is a known point. So this A is a known point. Just refreshing our minds of what vector equation is. A is a known point. T is the parameter. T is the parameter. And B is a known direction. So T is parameter. Para stand for parameter. And B is a known direction. Direction. All right, so now we can find the vector equation of the line, a plus t times b. So the known point that we can use either point A or point B. So let's use point A. So the points that they give us are 3, 4, and -7. So let's write down the points they give us, 3, 4, and -7. These are the points. And they give us point B, and point B is 1, -1, and 6. Point B is 1, -1, and 6. 1, -1, and 6. So let's say we're going to use the point. Let's use A. So A is 3, 4, -7, plus t times the known direction. Now let your known direction be vector AB. So that's a direction. Direction, it's the direction we're going to use is either AB or BA. I'm going to use AB. So the vector equation is equal to 3i plus 4j minus 7k. So I'm writing all of these in ijk now, plus the parameter t times vector AB. Vector AB is vector of the last minus vector of the first. 1 minus 3 is -2, so that's minus 2i. -1 minus 4, -1 minus -4 is minus 5j. And then 6 minus -7 is plus 13k. So that's the vector equation of the line. That's it. 3i plus 4j minus 7k plus t times -2 minus 5j plus 13k. That is option D. Here it is, option D. All right, so that's another new question, right? New question, brand new. Question 30. Question 30 asks us for the general solution of cosine 2 theta equal to the cosine of pi by 3. Now, if I tell you that cosine 2 theta is equal to cosine pi by 3, then the cosines cancel. And so what I'm telling you then is that 2 theta is equal to pi by 3. That must be clear. 2 theta is equal to pi by 3. But I just want to show you something about angles, right? Now, if I add 2 pi to any angle, it's going to be the same. For example, what do I mean by adding 2 pi? So what I'm trying to tell you is that the cosine of an angle 30, cosine of 30, I believe is, cosine of 30 is √3/2, something like that. And I can tell you that cosine 30 is the same as cosine 390, and that's the same as cosine 750. And so another way of representing all of this, I can say that the cosine of 30 is equal to the cosine of 390, where the cosine of 390 is the cosine of 30, plus I can say, in this case, it's 2 pi, which is equal to, in this case, it would be 2 times 2 pi, which is 4 pi. It's also equal to the cosine of 30 plus 4 pi. And I can go on to 6 pi, 8 pi, and so forth. So what I'm trying to say now is that the general solution then is that 2 theta is actually equal to pi by 3 plus 2n pi plus 2n pi. So now, but they want theta, the general solution for theta. So I'm going to divide everything by 2 to get theta is pi over 6 plus n pi. And when I say plus, it's really plus or minus. So that's pi by 6 plus n pi. That looks like option C. So this is also a new question. It's a brand new question. Easy, soft. So see how many new questions already? They're killing us with new questions this paper, but luckily for us, it was not 2020, it was 2019. All right, so that's question 30. So now we reach question 31, and this is where we get to module 3, differentiation, integration, and limits and continuity. All right, so now question 3. So let's look at it. We're differentiating this. So to differentiate this, right, what we learn is that we call one of them U and we call one of them V. And how we differentiate UV is VDU plus UDV, VDU plus UDV. So d by dx of all of that gives us V du plus UDV. That's what we get. So it's going to be x cubed. And when we differentiate sine x, we get cos x. So when we differentiate it, what we're getting is v, which is sine x times x cubed. Differentiate sine x, we get cos x. So we get x cubed cos x. I'm going to write c for cos x. So we're going to get x cubed cos x plus, this c stands for cos x. And then u so a VDU plus UDV. So now I need to differentiate that one to get 3x squared sine x. 3x squared sine x. I'm going to call S for sine x. So they have x squared in common. So we're going to factor out x squared. It's not so close to this question. So we're going to factor out x squared. Factor out x squared and we're left back with x cosine x plus 3 sine x, and that's option D. All right. All right, so that's it. That's question 31. Question 32 asks us for the limit as x goes to -1 of this function. So just plug in -1, and you're going to get -1 squared is 1, minus -1, -2 over -1 -1. And this is working out to be 0. So that's the answer for that question, 0. That's question 32. Question 33. Question 33 is asking us to find the integral of cos squared x over 4. So this question tells us that 2 cos squared x minus 1 is cos 2x. So from right up here, we can comply that cos 2x plus 1 is equal to 2 cos squared x. That's what they're pretty much telling us, 2 cos squared x. So now all we can do then is change x to x over 4. So let's change x to x over 4. And we can divide out by 2 to then say that the cosine of, let's change this to x over 4. So the cosine square of x over 4 is equal to, we divide through by 2, it's equal to cosine 2 times x over 4, 2 times x over 4 plus 1, and we're dividing that by 2. So what we can see is that cos squared x over 4 is working out to be 2 over 4 is just x over 2. So that works out to be the cosine of x over 2 plus 1 divided by 2. And so the integral now of this is equal to the integral of all of this. All right? That's what we have. Easy, soft. So let's simplify this side now. So I can factor out the half, and that works out to be a half the integral of cosine x over 2 plus the integral of 1. But the integral of 1 is just x. And so if you were to multiply this by a half, what we're getting is a half the integral of cosine x over 2 plus a half x. So that's option D, because it's half times everything right here. Half times all of this. So that's option D. Easy question. Soft. Question 34. All right, so this is not a new question. This question first came from 2015. So some persons like to think it's new, but this paper came in 2015. All right, that was the first time this question came. It says a dial on a plane preparing for landing registers 200 plus 5 sine h over h, where h is the height over the ground. Just as the plane lands, the dial reads, just as the plane lands, mean h is going to 0. It's not yet 0, you know, it's going to 0. It's very close to 0. But as h goes to 0, sine h over h, the limit of that is going to 1. Right? That's what it's going to. As h goes to 0, sine h over h goes to 1. And so what this means is that it is 200 plus 5 times 1. 200 plus 5 times 1 is 205. Easy, soft, 205. Question 35. Question 35 asks, it says the limit as x goes to 1 of x squared minus 3x plus 2 over x squared minus 4x plus 3. So that's what that question asks. So now in order to do this question, right, look at this question carefully. X squared minus 4x plus 3 and x squared minus 3x plus 2. If you're going to plug in 1, notice what we're going to get. If you plug in 1, you're going to get 1 minus 3 plus 2, which is 0, over 1 minus 4 plus 3, which is 0. Anytime you get 0 over 0, that is wrong. That is not true. Well, that means not equal to. So let's not write not equal to. This is false. Anytime you put it in and you get 0 over 0, then that is false. So that means you need to use some factorization principle to do it. Factorization principle. So let's do some factorization principle. So now what we need to do is divide both the numerator and the denominator by x minus 1. So let's do it on a fresh sheet of paper. So that's x squared minus 3x plus 2 and x squared minus 4x plus 3. So we have x squared minus 3x plus 2, and we have x squared minus 4x plus 3. And we need to factorize it by x minus 1. So we can just write divide both of them by x minus 1. We're going to divide both of them by x minus 1. All right. So now if we divide both of them by x minus 1, right? The factors aren't naturally coming to me. So let's just do it the division way, right? It always works out. So we're dividing it by x minus 1. So divide x squared minus 3x, x squared minus 3x plus 2 by x minus 1. What I'm getting is x into this leaves x. This times this gives me x squared. This times this. X times minus 1 is minus x. Subtract them. What I'm getting now is minus 3x minus minus x. That's what? 2x. That's minus 2x. Minus 3 plus 1 is minus 2 plus 2. And then this into this leaves minus 2. I don't know why this demo factorize easier to me. This is just x minus, yes. I didn't need to divide it. I see the factors now. See the factors. So this can be factorized easily. Don't even need to do that. I'm just going to rewrite it then as, this can be written as x minus 1 times x minus 2. I was only dividing because the factors weren't coming to me right away. Divided by x. That looks like minus 1, x minus 3. And so therefore, if I'm taking the limit now, the limit as x goes to 1 of this, the limit as x goes to 1 of this is the same as the limit as x goes to 1 of what's on this side. So this x minus 1 cancels the x minus 1. And so I'm left with the limit as x goes to 1 of x minus 2 over x minus 3. So when I plug in 1, I'm going to get minus 1. 1 minus 2 is minus 1 over 1 minus negative. 1 minus 3 is minus 2. And so I'm getting a half. So the solution is a half. Yeah. So the solution is a half. So that's option B. A half. Easy question, soft. This is also a new question. So let's write down N for new. Soft. Question 36. This is the most boring question on the paper. This comes every year. Option A. All we're going to do is use product rule or quotient rule and differentiate this. So y is equal to the root of 2x plus 1 is the same thing as 2x plus 1 to the half power. 2x plus 1 to the half power. That's what we have. And so y prime is equal to, we bring down the power, y prime, which is the same as dy by dx, is a half. Anytime you say prime, it just means first derivative. F prime of x, y prime, anything you want to call it. So y prime is 2x plus 1 Then you subtract 1 from the power to become minus a half times the differential inside the bracket, which is 2. Now this 2 cancels the half because 2 times a half is just 1. And so now the second derivative, which is y double prime, is going to be bring down this power now, bring down the negative a half, subtract 1 from the negative a half, which is 2x plus 1 to the negative a half minus 1 is negative 3 over 2 times the differential inside the bracket, which is 2. This 2 cancels the half. And so what we're left with is that the second derivative is minus 1 over 2x plus 1, 2x plus 1 to the 3 over 2. Give me a second. All right, so sorry about that. So as we were saying right here, we have 2x plus 1 now to the 3 over 2 power. How can you break up 3 over 2? 3 over 2 can be broken up as to the half power and times to the first power. And so that's why this can be written as option A. That's question 36. Because we just break this up as minus 1 over, using laws of indices, we can write it as 2x plus 1 to the first power times 2x plus 1 to the half power. That's what we can do. And that is option A. So we're almost finished, almost there. Question 37. Question 37 asks for a curve has equation y is equal to 16x plus 1 over x. What's the stationary points of this curve? To find the stationary points, we need dy by dx or y prime. So we're going to find dy by dx. So finding dy by dx is equal to, we differentiate 16x, we get 16. Now this 1 over x is x to the minus 1. Differentiating x to the minus 1 is minus x to the minus 2, which is minus 1 over x squared. That's how we differentiate 1 over x. Now stationary points occur when dy by dx equals 0. So we're going to set this equal to 0. So what we're solving is 16 is equal to 1 over x squared. So 16 is equal to 1 over x squared. And so what we're solving is x squared is actually equal to 1 over 16. And so if x squared is equal to 1 over 16, we square root both sides. And so we're going to get x is equal to plus or minus 1 over 4. When we square root both sides. Easy, soft, the capital T. All right. Question 38. Question 38. Question 38 asks us to find the constant A. And it says find the constant A under the premise that the gradient is equal to 0. Right? Find the constant A when the gradient is equal to 0. So the curve, this is the curve, and so what we need to first do is find dy by dx. So let's go ahead and find dy by dx. dy by dx is the gradient of the curve. So differentiate this, we're going to get 6ax squared, 6ax squared plus, this looks like 10ax plus, we differentiate 20x to get 20. All right, and look what this question says. It says the gradient is 0 when x is minus 1. So therefore, what they're telling is that when we plug in x as minus 1, so 6a times minus 1 squared plus 10a times minus 1, 10a times minus 1 plus 20, they're telling us that that is equal to 0. That's what it says. Yes, gradient is 0. So 20 plus 20 is equal to 0. So this entire equation simplifies to be 6a plus 10 minus 10a, that's minus 4a. Minus 4a is equal to negative 20. If minus 4a is equal to negative 20, then clearly a must be equal to 5. So that's the value of the constant. A is equal to 5. Easy, soft, the capital T. All right, question 39. Question 39 says, oh, this is a new question. Let me just write that down, new question, new. All right, now question 39. Question 39 says, which of the following real function has a point of discontinuity? Point of discontinuity occurs when the denominator is 0. So whenever you can set the denominator, den stands for denominator equal to 0, that's where point of discontinuity occurs. This denominator is never equal to 0, right? Because once you have x squared, that's a positive number, so this denominator is never 0. These two clearly have a denominator of 1, which is not 0. So the only one that has point of discontinuity is option A, and it is discontinuous when x is negative 1. That's question 39. Easy, soft. All right. Nice. That's question 39. Question 40. Yes, Daniel, go ahead and speak. Question 40. Question 40, it says, find the total area of A and B for the given regions. Now, what I want you to notice is that the area of A, I'm going to shade it in red. This is the area of A. Notice that it is above the x-axis, so it's going to come out positive. The area of B is below the x-axis, so it's going to come out negative, right? So in order to get the total area, we're going to need to take the modulus from 4 to 5. So the total area, I'm going to call it A. A is equal to the integral from 0 to 4 of the function plus the modulus of the integral from 4 to 5. Easy, soft, right? We have to take the modulus to get the correct area, because right here we're going to get a negative value. So let's say this part works out to be 10, and this works out to be negative 6. 10 plus negative 6 is 4. The total area is not 4. The total area needs to be 10 plus the modulus of -6, right? Because area cannot be negative. Think of this down here as a triangle, right? Triangle is half the base times the height. Let's say the height right here is, I don't know, let's say 6. And the base is 1, right? Since it's below the x-axis, we're going to get the area is a half of 6 times 1, which is 3. But in our case, it would be -3, but we don't want -3. It's the modulus of the -3, right? And so that's why we take the modulus. So that's the answer we're looking for. And that looks like option C. Here's it with the modulus. Option C, easy, soft. All right. All right. All right, Pearson. All right. We're almost finished as well, and I will make sure to send you the solution as well. All right. Yes, Errol, you can speak. All right. Question 42. It says, based on the diagram, which of the following statement is not correct? Not correct. Now look at this. All right, so I'm going to hurry up and finish because I know plenty of us will have to go soon. So let's hurry up and finish. It says, based on the diagram, which of the following is not true? Now look at this. F of A is undefined. And f of A also has no limit. So option B cannot be true. Option B cannot be true. The limit as x goes to A of f of x cannot be f of A because f of A is undefined. And so that's question 42. Easy, soft. Question 43. Question 43 gives us the displacement of a marble, and they ask us find the values of t for which the displacement of the marble increases. Now, distance is increasing when you're moving. Think about it. In order for me to walk a distance of 100 meters, I need to be traveling at a velocity. That velocity needs to be greater than 0. So once I give you S, they give us S, right? They give us S. They give us S. But then now the velocity that we want to find, the velocity is ds by dt. That's velocity. Velocity is distance over time, which is a differential of distance by the differential of time. So in this case, velocity is just going to be 12t squared minus 60t put some more space right here. 12t squared minus 60t and I differentiate 72t to just get 72. And I want to solve when the velocity is greater than 0. So I'm pretty much solving when 12t squared minus 60t plus 72 is greater than 0. All right. So since this is what I'm solving, I can divide through by 12 to get t squared minus 5t plus 6 is greater than 0. All right. So when is it going to be greater than 0? You can look at your solutions and try. Right? It's only going to be greater than 0 when t is less than 2 or when t is greater than 3. So for example, put t as 3. When t is greater than 3, 3 squared minus 5 times 3 plus 6, you're going to see that it is greater than 0. When t is less than 2, for example, 0, you get 0 minus 0 plus 6, which is still greater than 0. And so this has to be the solution. That's D. All right. Yes, Kyle, you can go ahead and speak. All right, so this question cannot be option C. It's not between, it's when it is less than 2 and greater than 3. All right, so many persons might be tempted to go with C, but in this case it's D. Now question 44 is C. So this question is easy. This is chain rule. We just bring down the power 3, subtract the power 2 times the differential of what's inside the bracket. That's going to be option C. That's question.
Sir, if I get 41, sir.
We get 41. Oh, I didn't even see this question. Thank you. Question 41 says f double prime of x is 6x. So since f double prime is 6x, we can find f prime of x by integrating f double prime of x. So f prime of x is equal to the integral of f double prime of x, which is 6x. When you integrate 6x, what we're getting is add 1 to the power, divide by the power. So integral of 6x is 3x squared plus some constant c. But notice what they said. They said f prime of 0 is equal to 0. And so what they're telling us then is that this constant c is 0. So they're telling us that f prime of x is 3x squared. If f prime of x is 3x squared, then f of x is the integral of f prime of x. So f of x then is the integral now. We're going to have to integrate again. So the f of x is the integral of 3x squared. So we're going to integrate 3x squared. Now integrate 3x squared. What we're getting is x cubed. X cubed. We'll integrate 3x squared, we get x cubed plus some constant c. So that is option D. That's option D. So that's question 41. Easy, soft. All right. Now question 45. Question 45, the last question. It is asking us for
Last thing.
yes, so finish strong. This is a new question as well. Finish strong. Integrate from 0 to pi by 2 of 2 cosine 5x. So let's see. We'll factor out 2 first, and we're integrating from 0 to pi by 2 of cosine 5x. So now, what we're going to get is 2 times, when you integrate cosine, well, when you integrate cosine, you get the sine of 5x.
1/5 cosine 5x.
And they divide it by 5, yes. Right? And so now we're going from 0 to pi by 2. Going from 0 to pi by 2, we can plug in pi by 2. So it's going to work out to be equal to 2 times. We'll plug in pi by 2. The sine of 5 pi by 2 over 5 is 1 over 5 minus the sine of 0 is 0. So this works out to be 2 times 1 over 5, which is 2 over 5. So that looks like option B. All right. So the key part to remember is when you integrate cosine 5x, we get sine 5x, but then we have to divide it back by 5. Right? That's the key thing. All right. So that's it. for 2019 paper. As we can see, lots of new questions, lots and lots of new questions.
Oh,
Right?
you are still on the 2019 paper, sir.
Yes. Because it's so many new questions, you know, it took a bit of time for us to do it. Lots of new questions, new question, new question, new question. All right?
Sir,
Yeah.
please, can you just remember to send all, you have your, first things first, do you have all the links from like 2008
Yes, I
up to
have all of
2019?
them. I have all of the links. So so people, what I'm going to do is I'm going to send all of the solution from 2007 to 2019. All right? I'm going to send all of the
The
papers
recordings as well.
and their solution in the
And the link.
email.
Yeah, the
Oh, and we
recordings.
want the link. We want the link for the class sessions as well.
Yes, sir. Can you just WhatsApp them to me?
All right. So
Also,
I'm going to send.
you can email it so I can bring it to my group, class group.
Yes. All right. So I'm going to email all of the links as well as the solutions for 2007 to 2019.
Also, sir, could you just indicate the
Yes,
year
I
past
know.
papers
Yes,
on the link?
I know how to. I will separate them, man. I won't leave it confusing.
Okay.
So what about specimen papers?
So I'm going to have a session tomorrow. So we can go through the specimen paper at 4. So anyone that is free, feel free to join. We're going to go through the specimen paper tomorrow. All right, Errol?
Yes, sir. Cool.
So at 4 p.m. tomorrow. All right, so I'm going to send the Zoom link to our emails as well, so we can join at 4. All right?